Okay, this question is about a double slit experiment. They've given you some data from the double slit experiment down here, and they've given you the equation for the double slit experiment, and the question is asking about uncertainty. So we need to determine the percentage uncertainty in the wavelength. Well, in order to get the percentage uncertainty in the wavelength, we need to add together, because we're multiplying these values together, we need to add together their percentage uncertainties. It tells you that D has a negligible uncertainty, so we need to figure out the percentage uncertainties of S and big D and add them together. So the percentage uncertainty of S is the value here is 0.9, the uncertainty here is 0.1, so it's 0.1 divided by 0.9 times 100. That'll give you the percentage uncertainty of S, which works out about 11%. And then the percentage uncertainty in big D is, here's your actual value, and the smallest scale division there is 1 millimeter, and it's measured using a ruler. So with an analog device like a ruler, the uncertainty is half of the smallest scale division, so plus or minus 0.5 millimeters. So that's an uncertainty of 0.5 millimeters divided by the actual value, which is 280 millimeters, which gives us an uncertainty of 0.0179%, I think. No, 0.179%. Okay, so then we know that the uncertainty of D is 0, little d, so then we can add together these percentage uncertainties and we get 11.179%. You should never state your uncertainty to more than two significant figures, so the uncertainty in wavelength, the percentage uncertainty in wavelength must be 11%. Explain how a student could use this apparatus to obtain a more reliable value for lambda. Well, in order to obtain a more reliable value for lambda, we need to decrease the uncertainty. The biggest uncertainty by far here is S, so how do we decrease the uncertainty for S? Well, we can't use any different equipment because it says use this apparatus. So the fringe separation is what we need to do. So you could do that in two ways. Either you can measure more fringes and take an average, which would reduce the percentage uncertainty in S. Or the other option is to increase big D, increase the distance from the screen, because that would increase S and therefore reduce the uncertainty, the percentage uncertainty in S. So there's two different ways to do that. Either one of those would have got you those 2 marks, provided that you said that the ultimate goal is to reduce the percentage uncertainty in S.